Welcome back, class. We're continuing with our topic of Earth's surface changes. Let's have a listen to this article.
Events that change Earth's surface. Events can happen quickly or slowly. You may not realize it, but Earth is changing every day. New landforms, lakes, and rivers are being made. Some old ones are disappearing. Some events cause changes that happen slowly. Weathering happens slowly over a long period. It happens over more years than you can observe. Wind and water wear away, or weather, rocks over many years. Other events cause changes that happen quickly. A volcano can erupt or blow up over just days. A landslide can happen in minutes. An earthquake can happen in seconds. A volcano can change land in days. Landslides and earthquakes change land in minutes or even seconds. Rapid changes, landslide. A landslide happens when rocks and soil slide from higher to lower ground. A landslide can travel as fast as 60 miles per hour, as fast as a car on a highway. A landslide changes the shape of the land very quickly. Heavy rainfall or snowfall can cause a landslide. Snow melting fast also can cause a landslide. The soil becomes so heavy with water that it slides down the hill. A landslide takes whatever is in its path down with it, including rocks and trees. A sandcastle that falls is a small model of how a landslide looks. Rapid changes, earthquake. Rocks that make up Earth's surface are pushed and pulled in different directions. Sometimes, this movement causes the Earth to shake. An earthquake is a shaking of Earth's surface that causes land to rise and fall. An earthquake can cause land to bend and break. An earthquake changes landforms by breaking them down and moving them. Deep cracks can appear suddenly in the ground. The land can bend and break. Yet an earthquake usually lasts only 10 to 30 seconds. An earthquake shakes the land. Buildings on that land can fall. Rapid changes, volcano. A volcano is a mountain with an opening at the top. When it erupts, there is a sudden burst of melted rock called lava that flows onto Earth's surface. Lava flows slowly so people can move out of the way. Most lava flows at less than a mile an hour. Lava blows out of the top of a volcano. A volcano can give warnings for days or even weeks with smaller explosions of gases before it erupts. When lava cools back into solid rock, new landforms are made. Lava burns whatever is in its path. Slow changes, weathering. Weathering slowly causes big changes to Earth's surface. Wind and water break rocks into small pieces. They move these pieces to new places. Wind can pick up rocks and reshape them. New landforms appear when dirt and rocks settle into new places. Old landforms become smaller or even disappear. These changes are gradual. They happen over thousands and even millions of years. A river flowing through solid rock can make a valley. Water crashing against rocks can reshape them.
So now let's try some of these questions. We're going to use the words landslide, erupt, earthquake, lava, and volcano. N may last only 30 seconds, but A may erupt for many days. So from the article we just heard, we know that earthquakes can last only 10 to 30 seconds, and a volcano can erupt for many days. How does weathering cause changes to Earth's surface? Wind and water can be a part of weathering. So wind and water break rocks into smaller pieces and then move them from one place to another. Now let's take a look at the parts of a volcano.
The parts of a volcano, flank. This is another word for the side of the volcano. Crater. This is the crater. It is the mouth of the volcano. This is where the lava, ash, and other things spill out of the volcano when it explodes. Ash cloud. This is called an ash cloud. It is a cloud of ash that is formed by a volcanic explosion. Magma. Underneath the surface, we will find magma. Magma is molten rock. Lava. Lava is molten rock that erupts from the volcano. As it cools, it hardens.
So now let's take a look at these questions. Circle the statement if it is true and place an X if the statement is false. So the crater of a volcano holds the lava. That would be false. When a volcano erupts, lava flows down the flanks. This is true because we said the flanks are the sides of the volcano. Here's a volcano eruption activity that we can do. You'll observe how a model of a volcanic eruption changes Earth's surface. Predict what will happen to the sides and surrounding Earth of a volcano when it erupts. So you would use safety goggles, a tray, small jar, clay, dishwashing liquid, spoon, baking soda, vinegar. So you're going to be molding something like a cone shape or volcano out of clay. And then you're going to be using the other ingredients or the materials to create a volcano. So what do you think would happen to the sides and the surrounding areas of the volcano when it erupts? It would get destroyed when the lava, or in our case, our baking soda vinegar mixture, falls on it. So be careful. Wear safety goggles to protect your eyes. Center the jar in the tray. Shape the clay around the jar to make it look like a volcano. Squeeze 2 to 3 drops of dishwashing liquid into the jar. Fill the jar halfway with vinegar. Add a spoon of baking soda to the jar. And then in the box below, draw or write about your observations. And communicate what happened when your model erupted. So you would see that the lava, or what we created to be some representing lava, would fall down the sides or the flanks of the volcano of our model. How did the quick eruption change the volcano and the land around it? Well, the lava changed the shape of the volcano it created, and one layer of rock around the land would also be destroyed or removed. So for this, I'll help you with the answers. The volcano caused damage to buildings, roads, and power lines. So things that are in the area get destroyed by earthquakes when it shakes. So for the volcano model activity, I'll be also sharing a YouTube link that you can watch about how to make and what would happen when you make the volcano model. That will be in the link in the description of this YouTube video. Now we're going to be exploring the digital interactive landslides on how a landslide can quickly change Earth. Answer the question after you have finished.
A landslide is the sudden movement of soil from higher to lower ground. Landslides can cause damage to homes, land, and the organisms that live in these places. Landslides are caused by several different actions. Erosion, rain, and gravity are the 3 main causes of landslides. Human activity can also be a contributing factor. Construction, farming, and poor irrigation have also been known to cause landslides. A landslide can move slowly, taking years to move even millimeters. Or a landslide can move quickly, creating debris in just seconds.
So what are the 3 causes of landslides? You can rewind this video. And if you remember, it's erosion, rain, and gravity. Let's do this together. Record data. Fill in the events that happen when the area floods. First, what happens when an area floods? Lots of rain falls and the water flows out of a lake or river. And then it continues to rain and the water rises. And then erosion, and gravity also make buildings and hills fall. So finally, you have an area that is flooded, which has buildings, trees, homes under water level, and broken down rock or mountains. Draw a before and after picture that shows a quick change to Earth's surface. So you'll need crayons or colored pencils. How can you draw a model of a quick change? So a quick change will have happened from things like volcanoes, earthquakes, or landslides, or even floods. So what does it look like before the volcano, for example, eruption, and what it looks after the volcano eruption? Recall what you have learned about the quick changes to Earth's surface, and then circle the change you would like to show in your before and after picture. So which change are you going to show? At what happens before and after an earthquake, volcano, landslide, or flood? Draw what the outdoor model looks like before the quick change happens. Label the landforms and Earth's surface. And now draw what the same model, outdoor model, looks like after the quick change. Label the landforms, Earth's surface, and the changes that happen. So you're going to label things like mountains, hills, maybe there's a valley. You could have homes, people, and then show what happens before the change and after the change. How do people change Earth's surface? 3 friends are talking about how people change the surface of Earth. Which friend has the best idea? Frankie says, I think people change Earth's surface in a good way. Casey says, I think people change Earth's surface in a bad way. And then Holly says, I think people change Earth's surface in both good and bad ways. So let's think about this for a little bit. So it's probably Holly who has the best idea, because Earth's surface can change in both good and bad ways thanks to people. People could plant lots of trees, and that adds greenery and oxygen and homes for animals. They could also remove plants or dig up holes or build factories and things that cause a lot of pollution. So there are both good and bad ways that people can add to Earth's surface. Look at the photo of the sandy beach. What do you notice about the piles of sand, and what questions do you have? So this is the sandy beach picture that we're looking at. So here's the piles of sand, and they're asking what questions you have about them. Maybe we could ask things like, how did the piles of sand get there? Why is there a fence in the middle of the piles of sand? Maybe we can also ask why there's grass in some areas of that sand. What happens to a beach when water and waves touch the sand? So for this prediction, we'll be using a tray, sand, water, and an empty bottle. What will you observe when you make a model of the beach and waves? When you have a beach or a sandy area and waves come on it, the waves will move the sand away. So you'll see the water pushing the sand, the piles of sand, away. Pour sand into one end of the tray and build it up to create a beach. Carefully fill the other end of the tray with enough water to touch the sand. Draw a picture of your beach model in the box below. And now lay a bottle across the tray in the water. Gently push it down into the water with your fingertips to create waves for 2 minutes. Observe what happens to the sand on the beach and draw a picture of what your beach model looks like now. So maybe at the beginning, you had sand all the way at the beginning, everywhere on the tray. And then after you added some water and you created some waves with your fingers, the sand would have been pushed, it would be flattened and pushed away. So what happened to the sand on the beach? It was washed out into the water. And how could you design a solution to keep the sand from washing away? So how would you stop the sand from washing away because of the water and the waves? You could build a wall at the edge of the sand, and that wall could stop the water from reaching the sand.
Playing on the beach and splashing in the waves makes for a great summer day. But did you know that waves can actually wear down and damage the beach over time? That damage is called coastal erosion. Today, we'll learn about the ways that people prevent coastal erosion and protect beaches. The first structure is called a seawall. Seawalls are made of concrete or steel and are built on the edge of a coastline to protect the beach and the buildings that are near the beach. Most seawalls are curved to stop the waves, sending their energy back to the sea. Another type of structure is called a breakwater. Breakwaters are strips of concrete or rock that jut out into the sea and have a seawall at the end. They retain sand to help bulk up the beach and provide a calm and safe area for swimming. A more natural way to prevent erosion is to plant specific plants on the shore. One example is beach grass. When beach grass is planted, the roots of the grass clump together under the sand to work like fingers, holding the sand in place, which helps to prevent erosion.
Now let's think of how beach grass helps prevent wind erosion. Well, beach grass acts as fingers because the roots go down into the sand and holds the sand together, so it prevents the wind from blowing the sand over and causing erosion. Breakwater are barriers that are built in the water to break the waves. Seawall are barriers that are built on the coast to protect sand and buildings. And beach grass is a natural way to slow erosion of sand. How can people help prevent changes to Earth's surface? They can build things and structures, such as the breakwaters and the seawalls, to stop the water from eroding the sand. And they can also plant things like beach grass to slow erosion of sand. So investigate how wind can affect the soil where farmers grow crops by conducting the simulation. Answer the questions after you've finished. What kind of windbreaks can this farmer use? Farmers can use things like tall grass, short trees, tall trees and bushes to break the wind, to stop the wind from affecting the soil. The moving arrows represent wind. Why do they change in size? If you were to see, as in the video we just watched, the arrows moving to represent the wind gets weaker after going through a windbreak. So that's why the arrows would be smaller. To represent stronger wind, they would draw bigger, larger arrows. Which windbreak protected the soil best, and why do you think so? The tall trees decreased the wind the most. So now explore the digital interactive ways to prevent land erosion on how people can build and plant in order to slow erosion, and then answer the questions after you have finished.
How do people prevent wind from eroding beaches? Fences are often put up near sand dunes to decrease the speed of the wind, so less sand is blown away.
So how do people prevent wind from eroding beaches? Fences are often put up near sand dunes to decrease the speed of the wind so less sand is blown away. Another way to prevent sand erosion is to change or block the direction in which water can travel. People do this by building breakwalls a little ways out of the coastline. Farmers use methods to slow down land erosion. They plow fields in curved rows that follow the shape of the land. This is called contour farming. Another method used by farmers to slow land erosion is called till planting. This is when farmers dig holes in the fields and place seeds in the holes. So how does planting fields in curved rows slow soil erosion? The soil does not blow far because it gets stuck in the curves. If it was in a straight line, the wind could blow it away easily. How does a breakwater slow water erosion? It slows down the waves so they don't hit the coast as hard, and this doesn't allow much erosion to happen.